of state the coordinates of the intersection of the terminal arm and the unit circle for the following. So if it says on the unit circle, you can go to your unit circle. They want the point at pi over 2. What is every coordinate on the unit circle? What? Cos then sine. So every single coordinate on the unit circle is actually the cos of that angle, the sine of that angle, the cos of that angle, the sine of that angle, correct? Yeah. So we're going to go 2 ways to check this. So go to pi over 2. Tell me what's there. 0, 1. Can we check it? Sure. We can go cos of 0. That's a lie. Cos of pi over 2. Oh, I have to erase it. Go back. Oh, thanks. Thanks, computer. Cos of pi over 2. If I'm typing pi over 2 in, what do I need to be in? Radian. And then sine of pi over 2. Type them in. Don't type it in with brackets and a comma. That is not productive. That's my coordinate. I want you to type in cos of pi over 2 in radian mode. If by resent you mean love it, yeah. So the mode you need to be in is radians because you're putting in pi over 2. So cos of pi over 2 gives you 0. Sine of pi over 2 gives you. Oh, that's aggressive. I don't know what you have happening. Your pizza's done. Okay. So negative 3 pi. Shh. We want to see it on the unit circle. Is negative 3 pi directly on the unit circle in front of your face? No. But we can find its coterminal, that is. So we're going to practice coterminals. So we're going to go negative 3 pi plus 2 pi, which gets me negative pi. Is that on? No. Negative pi plus 2 pi gets me pi. Is that on? Yeah. What's the answer at pi? Negative 1 and 0. Let's check it. Now, we're not going to check pi, because what if we made a mistake finding the coterminal? We're going to check it using negative 3 pi. We're going to use that negative 3 pi. So we're going to go cos of negative 3 pi, sine of negative 3 pi. What mode do we need to be in? The opposite. Radian. So type in cos of negative 3 pi into your calculators and sine of negative 3 pi. And you should get negative 1, comma, 0. C, 7 pi over 2, is that on your unit circle? No, you can't find it on there. It's too big. So we have to find its coterminal by going 7 pi over 2 minus 2 pi, which is actually the same as 7 pi over 2 minus 4 pi over 2, which is 3 pi over 2. Is 3 pi over 2 on your unit circle? Yes. What's the answer at 3 pi over 2? How can we check it? Cos of 7 pi over 2, sine of 7 pi over 2. Now for all these, they landed right on there. So these ones actually you could have gotten away with just putting in your calculator. The ones where it lands on like root 3 over 2, it's going to go 0.866, so it won't be exact values, so you'd have to convert it to an exact. But you'll probably memorize what those are anyways. Okay, 720. Is it on the unit circle? Is it too big or too small? Thank you. Okay, so we're going to go 720 degrees minus 360 degrees, which gets me 360. Is that on the unit circle? Yeah, it's at 1, 0. So I could go cos of 720 what? What mode do I need to be in? Degrees. And sine of 720 degrees. So now try that out. See if you get 1 and 0. Do you get 1, 0? Yeah. Okay. I want you to try A to G. And by G, I mean don't do G. I think we did G up here. Isn't that a repeat? Come on, Lepp. How about giving the same question twice? Like, seriously, who are you? What kind of person are you? Not a good one. Okay, A to F. Okay, 60. What's the answer to 6? Why am I putting an equal sign? What's the answer to 60? Half and root 3 over 2. What about 7 pi over 6? Negative root 3 over 2 and negative a half. What about 240?
Negative 1/2 negative root 3 over 2.
What about 120?
Negative 1/2 root 3 over 2.
These are all directly on the unit circle. What about negative 5 pi over 3? Is that on? No, so I'm going to go negative 5 pi over 3 plus 2 pi, which is actually the same as 6 pi over 3. So it would be pi over 3, which is and then 19 pi over 6, that's not on it. So I go 19 pi over 6, and I minus 2 pi, which is actually like minusing 12 pi over 6. So I get 7 pi over 6, which is right there. Negative root 3 over 2, and negative a half. So root 3 over 2 is like 0.8660, blah, 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 blah. So if you type it in, you would know that that's the exact value of it, right? What's root 2 over 2? Try that one out, because I didn't give you any. Yeah, it's 707, blah, 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 blah. So if you type it in and you get like a 0.707, that's root 2 over 2, right, Lucas?
Yep.
Yep. I mean schmookus. It was on the recording. I forgot. Okay, example 3, what is it asking here? It gave you the coordinate, it's going to want the thingy, the radian or the degree. Now the thing is both of them are answers that work, so we always have to be given a restricted domain, because what happens is, if not, I'd have to give her a general term answer to it, because it would keep going on for life, positive, and on for life, negative, all the coterminals, right? And you can't give an answer in degrees if your restricted domain is in radians. So this restricted domain is between 0, equal to 0, and 2 pi, not equal to 2 pi. So if the answer was on the 2 pi arm, you can't give that answer. Okay? So this is literally just asking for the radian measure on the unit circle. This one's a nice one, because I can make it not be there. I can make it be from negative pi to pi and such like that. So, negative 1, 0, where is that? At pi, and only pi. So help me, pi. Only 2 people smiled. All right, root 3 over 2.5. Pi over 6. What's 1 over root 2 the same as? It's just the unrationalized form of what? Root 2 over 2. So negative 1 over root 2 I gave to you because if you rationalize it from grade 11, you'd multiply by root 2 on the bottom, root 2 on the top. You get negative 1 root 2. And then what's root 2 times root 2? 2. Whenever you multiply two roots together that are the same, you just get the number, right? Because root 2 times root 2 is root 4, which is just 2. So it's actually just negative root 2 over 2 and root 2 over 2. Which we know, people are like, they look all over. Remember, the signs on the coordinate give you a hint as to which quadrant, oh my goodness, you're in. So if x is negative and y is positive, we're in quadrant 2. And when these are the same, we're actually a 45-degree reference angle, right? So that one's going to be at 135, which is actually 3 pi over 4. Now, negative, negative, we're going to be in quadrant 3, which whenever we start with a negative a half, it's actually a 60-degree reference angle. So it's going to be 4 pi over 3. Okay. Let me move over. Okay, example 4. This is something that is done really easily on a test if you remember this. So I highlight. I even made it bolded and I made them all caps. So if it says determine the missing y coordinate, whatever, and it says for each point on the unit circle. On the unit circle can mean two things. It can mean go to your unit circle, give me something off of it. Or on the unit circle can mean use the unit circle equation, which is x squared plus y squared equals 1. Now, why is it that? Well, it's because I'm going to explain to you why it is. The equation of a circle, which we used to do, is x minus h squared plus y minus k squared equals r squared. You don't have to do equations of circles except for the unit circle. I'm just going to explain to you why it's x squared plus y squared equals 1. So your hk on an actual coordinate on here, hk represents the center of the circle. And r is the radius, correct? Where is the center of the circle on the unit circle at? 0, 0, right? So we'd get x minus 0 squared plus y minus 0 squared. And what's the radius of the unit circle? So we get 1 squared. So that's why we get x squared plus y squared equals 1 when they say on the unit circle. Okay? Now, I told you this. You have quite a few coordinates on the unit circle in front of you, right? The coordinates are on the outside. You have quite a few. You think you have quite a few. But really, there's a ton more on that unit circle that are not drawn, correct? We're literally only giving the coordinates at 30s, 45s, 60s, and 90s. That's it. There's a lot of degrees that fall in between there, like 29 or 12 or 12.5, right? There's a ton of unit circle coordinates that we don't have on that unit circle, correct? So they can give us an x value on the unit circle and make us find the y. And we know that. If we have any type of variable, say we're given an x, we can always solve by a y if it's the only variable missing on an equation, right? So that's what we're going to do here. So this one here is at negative 4, 5, and y. But I always have to give you a quadrant. If I don't give you a quadrant, negative 4, 5, negative 4 fifths, let's say, if this is 1, negative 4 fifths is here. So I could technically end up having a y land down here or a y land up here, couldn't I? So I could have two answers. So if I don't give you a quadrant, you're going to give me plus or minus the y value. If I give you a quadrant, you have to tell me which one it is. I gave you quadrant 2, so what's my y going to be? My y is going to be positive. Let's plug it in and see. So this is my x, my y is y. So I always plug it into the unit circle. So it says on the unit circle, you can use the unit circle equation. So we're going to get negative 4 fifths squared plus y squared equals 1. That's negative 4 fifths squared. 16 over 25. Plus y squared equals 1. Then I subtract my 16 over 25, which is actually y squared equals 25 over 25 minus 16 over 25, which equals 9 over 25. So I have y squared equals 9 over 25. Then what can I do? Square root. Now please pay attention. You were taught this in grade 10. I haven't talked about grade 10 in a while, actually. It's back. Okay. In grade 10, you were taught this. If the radical, if the whole, fraction, are perfect squares, you can take the square root of the whole thing, right? And I'm going to get 3 over 5 for this one. That's true. But I'm going to show you up here. You were taught in grade 10, sometimes you'll be given, you'll get an answer of 3 over 25. And when you go to square root it, both of them aren't perfect squares, right? We'd also have to remember when we square root anything, what do we always have to do? Yes, plus or minus signs. So I would end up with this, right? And if I type that in, I'm going to get an ugly decimal, aren't I? What we were taught in grade 10, though, is if one of them is a perfect square and one of them is not, you can take the square root. Instead of putting it over the whole fraction, you can put it over both separately. So I could go like this, actually, for this one. I could go root 3, which is fine, and then root 25. And so I would get plus or minus root 3 over 5. And then my denominator is rationalized, right? So you were taught in grade 10 that if you can do the whole fraction, if it's a full perfect square, great. Do the whole thing. If you can't, you can split it. Top and bottom, and then take the square root of the one that actually is a perfect square. Okay? So the answer to this one is going to be y equals plus or minus 3 over 5. If you box that, though, you're wrong. Because what does it actually have to be? Positive, because it's in quadrant 2. So my answer is actually y equals 3/5. You try B, C, D. And that's how you do the last question. You're all here, honestly, you'll be fine.